A disturbing yet not really surprising article or post was published by Anthropic yesterday. An article about an AI orchestrated cyber espionage campaign, a cyber attack carried out with help of AI, with help of Claude code. And it's an interesting article. I already read it and I want to go through it together with you here. So, Anthropic in this article describes a cyber attack on various companies that was carried out almost entirely with help of AI, almost entirely with help of Claude code, by jailbreaking Claude code, by getting it to do things it normally shouldn't do. And let's take a close look at how that played out. In mid-September 2025, we, Anthropic, detected suspicious activity that later investigation determined to be a highly sophisticated espionage campaign. The attackers used AI's agentic capabilities to an unprecedented degree, using AI not just as an advisor, but to execute the cyber attacks themselves. And that is huge, that you can already use AI that is published by Anthropic, AI models by Anthropic, and the Claude Code tool by Anthropic to carry out cyber attacks. And here's why that is important. Today, we're living in a world where the most capable models are the models by OpenAI, Anthropic, X, Google, and of course we got some very capable Chinese models too. But we're still at a point in time, on a timeline, we are still at a point in time where most of these models and the most capable models are controlled by companies, most of them by companies in democracies. Now, I'll not say that these companies are saints or don't do bad stuff, but they're not bad actors in the sense of this article. They're not cyber attackers, obviously. However, in the future, in the not too distant future, we will be at a place where these models, these very capable models, will also be owned by bad actors themselves. So right now, here in this article, we're talking about a cyber attack that was carried out with help of Anthropic and Claude code. And it's bad enough that this is possible, that you can trick those tools and models into doing stuff they shouldn't do. And we'll get back to how that happened, of course. But that is today. We still have to apply tricks to abuse these models. In a future, these models will simply belong to the bad actors themselves. There will be open models that are capable enough of doing that. So then certain control mechanisms, to which we'll get back here in this article, won't even be there anymore. We'll be in a future where bad actors have direct, uncontrolled access to very capable models that can be fine-tuned for their purposes, that can be trained for their purposes, that can use tools that were purpose-built for malicious stuff. That is where we're heading to. And even today, where we're not there yet, or where this is still a niche, even today, we have fully or almost fully AI-controlled cyber attacks. So this is definitely a scary article and a scary future, which makes it very clear that cybersecurity and preventing attacks will be a super big challenge. It always has been, but now with AI, where everything can be quicker and more automated and harder to trace back to individuals, it will be an even more important topic. But back to this article. The threat actor, whom we assess with high confidence was a Chinese state-sponsored group, manipulated our Claude Code tool into attempting infiltration into roughly 30 global targets and succeeded in a small number of cases. So it was not just an attempt, they succeeded. The operation targeted large tech companies, financial institutions, chemical manufacturing companies, and government agencies. We believe this is the first documented case of a large-scale cyber attack executed without substantial human intervention. This is so big, without substantial human intervention. And again, that is why this is such a scary future where bad actors don't even need to rely on these controlled AI models, which they still have to rely on today. Upon detecting this activity, we immediately launched an investigation to understand its scope and nature. Over the following 10 days, as we mapped the severity and full extent of the operation, we banned accounts as they were identified. So again, these were really regular Claude accounts. These people were using Claude, the model hosted by Anthropic. They did not kind of steal it, run it on their own servers, or use their own trained models. They used the models you can use too via the Claude API or via Claude Code. This campaign has substantial implications for cybersecurity in the age of AI agents, as I just said, because everything can be automated, and it's already possible today where there are guardrails in place. And again, think of that future where we have no guardrails, or where the bad actors don't have guardrails. These attacks are likely to only grow in their effectiveness. To keep pace with this rapidly advancing threat, we have expanded our detection capabilities and developed better classifiers to flag malicious activities. And that's the important part here. This is what Anthropic is trying to do today to make sure that their models can't be abused for malicious tasks, that Claude Code can't be abused, and ultimately the models they're exposing via their APIs, which Claude Code uses in the end. This all won't matter at all in the future. Because in a future where bad actors themselves have their own models running on their own servers, these guardrails won't matter. Well, obviously, they will still matter. Obviously, you still want to make it easier than it's necessary. And obviously, not all bad actors will have their own malicious models. But especially if we're talking about state-controlled bad actors or big cyber attacker groups, let's be real. Of course, they will have access to their very own models on their own servers. So this will not matter at all in that future. Obviously, it will matter still because you don't want to make it easier, and it will at least filter out a significant group of potential bad actors that don't have access to their own models. So yeah, it's important, but it will not be enough. Companies themselves need to ramp up their cybersecurity game, which is easier said than done, because it has been true for the last 10 years, of course, even without AI, but it's becoming even more important in the age of AI. So yeah, that is the big problem here. Now, let's see how the cyber attack worked. The attack relied on several features of AI models that did not exist or were in much more nascent form just a year ago. Intelligence. Models' general levels of capability have increased to the point that they can follow complex instructions and understand context in ways that make very sophisticated tasks possible. Not only that, but several of their well-developed specific skills, in particular software coding, lend themselves to being used in cyber attacks. Sure, because now with models that are smarter, and just to be very clear here, we're still talking about models that just generate tokens, but of course, by generating these tokens they are able to describe the usage of tools, and by using tools, they become more capable. With all the fine-tuning they received, they also generate more tokens that are likely to be, or more likely to be, the tokens you want to generate. So that is what intelligence means here. They're not really intelligent, but they have been tuned, especially for software development, such that they are much more likely to generate meaningful output, and especially also output that allows them to describe tool use and then use those tools. So execute code that does something, for example, send an HTTP request and so on. And it's that combination that makes them more capable in the end. And of course, yeah, that's exactly what you need for automated cyber attacks, because you need a model that's able to write code, follow your instructions related to that. You need a model that's able to send HTTP requests, phishing emails, whatever. And all that is what these models can do quite well in the end. Agency. Models can act as agents, that is, they can run in loops where they take autonomous actions, chain together tasks, and make decisions with only minimal occasional human input. That's another important step. This is what allows these systems, or these attacks here in this case, to work with only minimal human input. Because these models and the software that uses these models can go for so much longer, and it's important to differentiate here. The model is still just the thing that receives a prompt and sends back some tokens. That has not changed. But it's the software, Claude Code, for example, that then takes that output and sends back another message to the same API with that output, with the original task, with some meta instructions like, please check if that output answers the question by the user. You got these tools available. Please tell me if you want to use a tool. That's how the software around the models in the end makes these models more capable, not because the model does everything on its own, but because the model is capable of giving the software the result it needs. The software then feeds these enriched results back to the model, and it's this loop that keeps the whole system going and that leads to these agentic systems that can go on for longer, that can use tools, and that require less human input. And yeah, tools, that is therefore the other missing piece here, of course, that models have access to a wide array of software tools. They can now search the web, retrieve data, perform many other actions that were previously the sole domain of human operators. In the case of cyber attacks, the tools might include password crackers, network scanners, and other security-related software. Because again, it's not all just GitHub MCPs. It can be all kind of tools you could expose to your model or to the software that uses these models and that runs these agentic tasks. So they got a nice diagram in this article, but in the end, the attack played out relatively simple. They describe it in greater detail down there. They convinced Claude Code to do stuff it normally shouldn't be able to do. They had to convince Claude, which is extensively trained to avoid harmful behaviors, to engage in the attack. They did so by jailbreaking it, effectively tricking it to bypass its guardrails. And that's the part where Anthropic is now trying to get back better, not just in Claude Code, but in the models themselves. So on their API, where they scan all the requests that reach their models, so to say, and they try to do a better job at detecting prompt injections in the end. Because these attackers broke down their attacks into small, seemingly innocent tasks that Claude would execute without being provided the full context of their malicious purpose. They also told Claude that it was an employee of a legitimate cybersecurity firm and was being used in defensive testing. That's the good old trick. I think that is how jailbreaking was already done 2 years ago with the early ChatGPT models. You tell it that you need this information because your aunt's dying, and it'll happily expose its system prompt. Kind of a simplification, but that's still how prompt injections can work these days, that you try to apply various techniques, and there are very interesting techniques when it comes to that, including the use of special tokens you might include in your message to get the model to generate output it normally shouldn't generate. The attackers then initiated the second phase of the attack, which involved Claude Code inspecting the target organization systems. So yeah, that's then essentially what Claude Code did. Then, with minimal human input, it is in the end then used its agentic capabilities, its tools, to really scan networks, write code, and do all that stuff without a human telling it exactly what to do. So it was, as mentioned earlier, a fully or almost fully automated attack. So in the next phases of the attack, Claude identified and tested security vulnerabilities in the target's organization systems by researching and writing its own exploit code. Having done so, the framework was able to use Claude to harvest credentials, usernames, and passwords that allowed it to further access and then extract a large amount of private data. So it did really research and write the code to get into systems of other companies, and then in those systems write more code to extract data and compromise these systems and then do bad stuff in there once it was in there. The highest privilege accounts were identified, backdoors were created, so that's all the stuff that happened after it was in the systems, and data were exfiltrated with minimal human supervision. In a final phase, the attackers had Claude produce comprehensive documentation of the attack, creating helpful files of the stolen credentials and the systems analyzed, which would assist the framework in planning the next stage of the threat actor's cyber operations. Overall, the threat actor was able to use AI to perform 80 to 90% of the campaign, with human intervention required only sporadically, perhaps 4 to 6 critical decision points per hacking campaign. That is nothing. That is nothing. That is such a scale at which you can run these attacks. And again, especially in a future where you don't have to work against certain guardrails, where you can just focus on getting the job done and you have to spend energy on getting around guardrails. That is really a scary future. This degree of automation is really, really scary here. Claude didn't always work perfectly. It occasionally hallucinated credentials or claimed to have extracted secret information that was in fact publicly available. This remains an obstacle to fully autonomous cyber attacks. And this is not just an obstacle for cyber attacks. This is, of course, an obstacle for everybody, for us developers too, because hallucinations are a problem and will stay a problem because, as I mentioned before, it's so easy to forget, but these are token generation machines. Always have been, always will be. The large language models, I mean. They are generating tokens, and they are generating the most likely token as the next token based on all the tokens that came before it. And that is something that can and always will have the danger of hallucinating. So that, of course, is a problem in general. Good to see that it can then also be helpful when it comes to defending against malicious tasks, because those also are hurt by hallucination. But of course, that is a general problem we face, and it will not be a significant defense mechanism, unfortunately. Because in the end, if everything's automated, it's just a question of scale. And if some attacks fail because of hallucination, well, does that really matter if you can run thousands of attacks in parallel? I'm not sure it does. Cybersecurity implications. The barriers to performing sophisticated cyber attacks have dropped substantially, and we predict that they'll continue to do so. With the correct setup, threat actors can now use agentic AI systems for extended periods to do the work of entire teams of experienced hackers. So kind of the same thing that applies to normal software engineering, where you can also be more productive with AI. And I got a video coming up on that too, by the way. Just that is the case for malicious tasks. It's maybe even worse, because there you don't even have to care about things like code quality. Obviously, you want to have a successful attack, but in the end, if everything's automated, you also can care a lot about just the scale. And if you can automate thousands of attacks to run in parallel, it doesn't really matter to you if you might have code quality problems or anything like that. So already with the systems today, where you could argue about potential problems they have when it comes to generating code, a lot of that might not matter for attacks like this, because you need a result that's just good enough. And again, chances are definitely high that results will also get better in the future, and we'll be dealing with systems that don't even have guardrails. And as they say here, less experienced and resourced groups can now potentially perform large-scale attacks of this nature. This attack is an escalation even on the wipe hacking findings we reported this summer. In those operations, humans were much still in the loop, directing the operations. Here, human involvement was much less frequent. And although we have visibility into Claude usage, this case study probably reflects consistent patterns of behavior across frontier AI models and demonstrates how threat actors are adapting their operations. By the way, this is one case that was caught by Anthropic. Not sure if all the cases are being caught, also by Google, OpenAI, and so on. This raises an important question. If AI models can be misused for cyber attacks at this scale, why continue to develop and release them? The answer is that very abilities that allow Claude to be used in these attacks also make it crucial for cyber defense. Well, that's kind of a weak argument, I'll say, because if you have one thing that makes a problem much bigger, saying, yeah, but it can also help with the solution, kind of bad, right? So I'm not really sure about that. If we would not have these models, and just to be clear, that is not something that's going to happen, but if we would not have them, it would probably be better than if we had them in the context of cyber attacks and defense, because if you're in the defense, you will always be one step behind. So I definitely see these tools more as an advantage for the attackers and a big disadvantage for the companies that have to defend against these attacks. So that's kind of a weak argument. My argument would be, it doesn't matter if Anthropic, OpenAI, and so on continue developing AI models. And obviously they will, just to be very clear. And there are way more arguments to be made against AI than just cybersecurity. This is just one very important and problematic field, but there are tons of discussions, including philosophical discussions we could have about AI and if it's good that it's there or not, but they all don't matter. It is there, it will stay there, and of course these companies will continuing to develop these models. And even if they wouldn't, the technology is there. Bad actors will have access to their own models in the future. It does not matter at all if companies like Anthropic or OpenAI continue. The technology is there, and the problems with it are also there, therefore, and they will stay here. That would be my argument. This argument here doesn't make too much sense to me. And therefore, definitely scary. A scary world, also from a cybersecurity perspective. As I mentioned, I only see that becoming worse in the future, and therefore maybe a career in cybersecurity is worth a second look, because yeah, that will be important.